Hello, welcome to the first lesson in the first module of my new course on networking fundamentals. In this module, we'll be exploring how data flows through the internet. Crucial to that is understanding the various devices which are involved to make that possible. In this lesson, we'll be exploring these various devices and their related concepts. We'll be doing this in two parts. In this video, we'll unpack hosts, IP addresses, and networks, and in the next video, we'll explore these devices. And let's just jump right into it by defining our first term, host. Hosts are any device which sends or receives traffic. For example, your computer is a host, your laptop, your phone, your printer, your servers, those are all considered hosts. But we're also in the cloud days, which means there's many cloud resources that can also be considered as hosts. Cloud servers, for example. Moreover, we're also in the Internet of Things days, which means anything you have at your house that sends or receives traffic is also considered a host. That smart TV you stream to, those speakers that are all synchronized with each other, smart watches, your thermometer that you can control remotely, that refrigerator that reminds you when you're out of milk, all of those devices are sending and receiving traffic, and therefore can be considered as hosts. Why this is important is because all of these devices follow the same rules for how they communicate to the internet. Later in this module, we'll be looking at everything a host does when sending or receiving data from the internet. In doing so, we'll actually be explaining how all of these devices communicate with the internet. Hosts typically fall in one of two categories, clients or servers. Clients are the hosts that are initiating the request, and servers are the hosts that are responding to requests. For example, let's just say this is the web server for the website www.site.com. Well, when this computer over here is making a request to ask for the website site.com, it's initiating a request and therefore it is considered the client. When the web server site.com is providing the content for site.com, it's responding to the request, therefore it is considered the server. Keep in mind, however, the terms client and server are relative to a specific communication. Meaning, at some point, this web server is going to have to update its files from a file server or a database server. Well, for that, the web server has to make a request to the file server to ask for new files. In that communication, the web server is the client and the file server is the server. We can take it a step further. This file server at some point might need to run some sort of software update. Well, when it's making the request to the update server to download the new software, it's acting as the client, and when the update server is providing the updates back to the file server, it's acting as the server. So the terms client and server are specific to the communication that is occurring. Now we've been calling this a web server, but I want to clearly define what that is. A server is nothing more than a computer with software installed which knows how to respond to specific requests. This guy right here is really just a computer that has software installed that knows how to serve web pages. You can turn any device into a web server by simply installing the proper web server software. It's the same way with the file server and the update server we discussed a second ago. In the end, they are merely computers with software that knows how to provide files or provide updates. Each server you encounter is simply a computer responding to requests. So that wraps up our discussion on hosts. Next, we want to define IP addresses. IP addresses are the identity of each host, and every single host must have an IP address if it means to communicate on the internet. Just like you need a phone number in order to send or receive phone calls, or you need a mailing address in order to send and receive mail, you need an IP address in order to send or receive packets on a network. This is what the IP address is. It is the identity of every single host. Now, these IP addresses are actually going to be stamped on everything that each host sends. For example, when this client over here makes a web request to site.com, on this packet, which includes what web page it is asking for, the client is going to stamp the source and destination IP addresses. The source IP address is going to be the client's IP address, and the destination IP address is going to be the server's IP address. In the same way, when the server responds by providing the web page, it's also going to stamp the source and destination IP addresses for that communication. Here, the source IP address will be the server, and then the destination IP address will be the client. Everything sent on the internet is going to have this source and destination IP address. Now, an IP address itself is really just 32 bits. A bit is a 1 or a 0, which means every single IP address is really just a different combination of 32 ones and zeros. What we do is we take those 32 bits and break them up into 4 chunks, which we call octets, and we convert each of those octets into a decimal number. This is how we get to what we know of as an IP address. The smallest binary number you can get with 8 bits is 0, and the largest binary number you can get with 8 bits is 255. That's why every IP address you come across is going to be 4 instances of the numbers 0 through 255. Now in this module, we're not going to be exploring binary. We've already created some videos that discuss binary. If you're interested in learning about binary and how this conversion happens, please check out those videos. There'll be a link in the description. Either way, that is what an IP address is. Now, these IP addresses are typically assigned in some sort of hierarchy, so let me explain that. Imagine this is the Acme Corporation, and the Acme Corporation owns every IP address that starts with 10.anything. Well, maybe the Acme Corporation has 3 different offices, one in New York, one in London, and one in Tokyo. And each of those offices is going to have a subset of the Acme Corporation IP space. New York might have everything that starts with 10.20, London might have everything that starts with 10.30, and Tokyo might have everything that starts with 10.40. Moreover, the New York office might have a few different teams. For instance, they might have a sales team, an engineering team, and a marketing team. And each of those teams would have their own dedicated IP address space. The sales team could have everything that starts with 1020.55. The engineering team would have everything that starts with 1020.66, and marketing would have 1020.77. The London and Tokyo offices probably have those same teams as well, but each of their IP address space is going to start with the prefix for that particular location. This allows the IP address to sort of pinpoint where a particular host exists. For example, if we had the IP address 10.30.55.127, that IP address is the identity of a host that sits in the Acme Corporation, in the London office, on the sales team. Now, this breaking up of IP addresses into their different hierarchies is done through a process known as subnetting. In this module, we're not going to be covering subnetting, but we've already created some videos discussing how subnetting works. If you're interested in learning subnetting, please check out those videos. There will be a link in the description. For us, we're going to continue with our exploration of network devices. All of the hosts that sit inside each of these teams at each of these offices exist in what is known as a network. A network is what actually does the transportation of traffic between hosts. In its simplest form, anytime you connect 2 hosts, you have a network. If you plug these hosts directly into each other, you have a network. Before networks, in order to move data from this computer to this computer, you would literally have to walk up to this computer, plug in a disk, download some files, then walk over to the other computer, plug in that same disk, and upload those files. Networking and networks are what automated that process. They allowed these computers to share data with each other automatically. Now, if we take a step back, a network is really just a logical grouping of hosts which require similar connectivity. So let me explain that. At your house, you probably have some sort of home Wi-Fi network. On that network, you've got your computer, your printer, laptops, phones, a bunch of different devices which all have similar connectivity profiles, meaning they just use the internet or check email or something along those lines. Well, down the street from you, there might be a coffee shop that provides Wi-Fi for its tenants. And that coffee shop is going to have various customers that have various mobile devices that are all connecting to the internet. Well, these devices all have similar connectivity profiles. They just need access to the internet. But since they're coming from a different location as these devices, they are grouped into 2 separate networks. Now, networks can also contain other networks. For example, you probably have a school not too far from where you live, and that school has its own network. But within that school are a bunch of classrooms, and it's very possible that inside each of those classrooms, all the hosts in each classroom are grouped up into their own network. Now, these networks within other networks are sometimes referred to as subnetworks or subnets, and this is a very common occurrence on the internet. In fact, that illustration we just did with the Acme Corporation, with the 3 offices and the 3 different teams in each of these offices, well, the office location is a subnet of the Acme Corporation IP space. And the specific teams are a subnet of the New York IP space. So you can have networks within networks within networks. Either way, all of these networks then connect to each other. For example, you might be sitting at your house and might want to do some sort of working from home and be able to access the office networks. Or possibly you're studying from a coffee shop and you might want to access school resources. Well, instead of having each of these networks connect directly to each other in every possible combination, instead, all of those networks are connected to a central resource. namely the internet. In fact, what we know of as the internet is simply a bunch of interconnected networks. That's all the internet is. It's just a bunch of company networks connected to a bunch of school networks connected to a bunch of customer networks. Of course, what handles those connections are often the internet service providers, or the ISPs, but that goes a little bit deeper than we want to get at this point. Either way, that wraps up our discussion on hosts, IP addresses, and networks. In part 2, we'll continue our discussion by unpacking repeaters, hubs, bridges, switches, and routers. The key takeaway from this lesson is understanding what hosts are, understanding the designations client and server, understanding what IP addresses are and their hierarchical nature, and understanding what a network is, specifically that it is a logical grouping of related hosts which require similar connectivity. I hope you enjoyed this lesson. I want to thank you for watching, and we'll see you in the next one. Hey YouTube, I hope you enjoyed that free lesson for my new course on networking fundamentals. I'll be releasing the entire first module for free on YouTube. I want this course to be the ultimate networking fundamentals course, and since I'm still scoping out the outline for the rest of the course, you can have a say in what topics will be covered. Let me know in the comments below what subjects you want included in this course. Otherwise, remember to like and subscribe and click the notification bell so you know when the next lesson releases. And of course, if you enjoyed this lesson, the best way to say thanks is to share this video with your friends. I hope you enjoyed this lesson, and I want to thank you for watching.